Hello everyone, welcome to lesson 8-2, volume of cones. Let's jump right into the real world link. Carnival. Grace and Elle are making snow cones for the school carnival. They want to know how much ice goes into a paper cone that has a radius of 1.5 inches and a height of 4 inches. So we have a cone, right? A cone, and they're telling us that our height from here to here is 4 inches, and our radius from the center out is 1.5 inches, right? Number 1, recall the formula for finding the volume of a rectangular pyramid. The volume is 1/3 of the base times the height. How does the volume of a pyramid compare to the volume of a prism with the same base and height? Well, a prism is a three-dimensional rectangle, right? And we have the a pyramid. When you compare the two, the volume of the pyramid is actually 1/3 the size of the prism. So essentially, you could fit 3 of the pyramids inside one prism. What is the formula for finding the volume of a cylinder? If you guys recall the last lesson, we said that volume equals area of a circle, right? Pi r squared times the height, correct? And question 3, what is the volume of a cylinder with the radius of 1.5 inches and a height of 4 inches? Well, if we find, this would help us find the cylinder, right? And we would take the dimensions from the cone to find the cylinder. Well, that would be, essentially, I would replace volume equals pi r squared, right? And now I'm going to replace those variables. And I get my pi, and then the radius is 1.5 squared, and my height is 4 inches. So this is the cone, but we're using this pretending it's a cylinder. And that would actually give me a volume of 28.26 inches cubed, right? Because we're talking about volume, so it has to be cubed. Now, how does that compare to a cone? Well, the volume of the cones Grace and Elle are using is about 9.42 cubic inches. Write a ratio in simplest form comparing those two numbers. So if I take this number and I compare it to this number right here, if I compare those two numbers and write a ratio and then simplify it, what would I get? Well, let's see. Let's say I were to write the 9.42 right here. 9.42 over 28.26. Now, I have not simplified that yet, but if I were to simplify the two, I would actually get, and dividing both by 3, I would actually get 1/3. Sorry, not dividing by 3, but I would ask myself, is this number in this number, and how many times? Well, it is. It's 1/3, right? So what can we conclude about that? We can say that the volume of a cone is 1/3 the volume of a cylinder. So volume of a cone is 1/3, right? The volume of a cylinder. Here's the volume of a cylinder. Remember that? Here's the volume. Pi r squared times the height. That's our cylinder, what we did last lesson. And to get 1/3 of this, we have to multiply by 1/3. So that is the formula for our cone. Now, we do not have to put in the brackets. And that's it right there. Okay? That's the formula we're going to be using for this lesson. And here is the formula officially. Volume of a cone. The volume V of a cone with the radius r is 1/3 the area of the base times the height. So 1/3 the area of the base times the height. Essentially 1/3 of the area of a cylinder, right? And there it is, 1/3 base times height, or simply 1/3 area of a circle times the height. You see that? And that's the one that I typically like to use. Okay, a cone is three-dimensional figure. It's a three-dimensional figure with one circular base connected by a curved surface to a single vertex. That right there is the dictionary definition of a cone. Don't be surprised if that comes up on a quiz or a test. Example 1. Find the volume of the cone, round to the nearest tenth. Here we have our formula. We have a cone that's 6 inches high and 3 inches radius. We plug in our variables. We multiply straight across, and then simplified, we get 56.5. I'm sure we had to round that. So the volume is about 56.5 cubic inches. Okay, if you got it, it's your turn to practice. Please pause the video, try the formula with A and B, and then play to check your answer. Okay, I hope you're ready to check. Here's A. I've written down my formula. Volume equals 1/3 pi r squared times height. Now let's replace our radius, which is 2, and our height with 7. And then let's solve by doing exponents and then order of operation, but simply multiplying straight across. So we know that this 2 will become 4. So I'm just going to jump right ahead and go 4 times 7, or 1/3 times 3.14 times 4 times 7 equals volume equals 29.3, and this is feet, so it's feet, and it's cubed because we're talking volume. Okay, now let's check B. Again, let's write down our formula. Volume equals 1/3 of pi r squared times height. We have, this time we're being given the diameter. Don't forget, that's the diameter, the distance all the way across. So we need half of that for our radius. So our radius will be 12 millimeters, right? That's our radius. So let's use that. And our height is 26, as you can see right there. So let's replace our variables. So we have replaced our variables in blue, and if we were using, we have to use order of operations. So first we have to use solve for the exponent, and 12 times 12 is 144. So this right here is 144. So we have 1/3 times 3.14 times 44 times 26 equals, obviously you can insert one more line. You know what? I'll do it just for the sake of doing it. I'm going to insert the other line. And now I will go right ahead and multiply straight across. And when I do so, I get volume equals, remember I am going to round to the nearest tenth. I get 3,920.7 millimeters cubed. Okay, I hope you got that too. Now let's look at example 2. And here we are going to look at a cone-shaped paper cup is filled with water. The height of the cup is 10 centimeters and the diameter is 8 centimeters. What is the volume of the paper cup? Round to the nearest tenth. So now we're just simply taking our scale and applying it to a real world context. They're giving us diameter, so make note of that. The diameter is 8 centimeters, so that means our radius is half of that, which is 4, right? And our height is 10 centimeters. So when we plug in those numbers, you can see they're being plugged in right there. And when we multiply straight across, we get the volume. So let's try that now. Let's read it together, and when I'm done reading, you can try it on your own. April is filling 6 identical cones for her piñata. Each cone has a radius of 1.5 inches and a height of 9 inches. What is the total volume of the cones? Round to the nearest tenth. Okay, let's just point out some of the important information. We are being given the radius, the height, and they're telling us that there are 6 identical cones And that's important because they want the total of the cones. Notice, plural. So whatever answer we get for 1, we have to multiply times 6. So go ahead, pause the video, and try this on your own. Pause now. Okay, I hope you paused the video and you're ready to check. So we have volume equals 1/3 pi r squared times height. And all of this, if we want to actually get the volume of all the cones, so maybe I can put on here volume of cones, just so that we know we're looking for more than 1. We have to multiply this entire equation by 6. So there's 6 of them, correct? So that would be the more correct formula. Let's go ahead and replace our variables. And we have something that looks quite complicated, but I think you are able to follow. We have a nested parentheses because I'm using brackets in here to multiply, so I needed to use the square brackets to replace these ones, right? So I still have 1/3 times pi times my radius squared times my height, and then when all that's done, that's going to give me the volume for 1 cone. And remember that it needs to be multiplied times 6 because there's 6 identical cones and they want to know the total volume of the cones. Okay, so we can solve here. Remember 1.5 times 1.5 first, and then multiply that product times the other factors, and we get 21.19499. So I'm just gonna write 195 and stop there. And that's being multiplied times 6. So when I multiply that value times 6, I get 127.16. So it's 127.16, which is decimal 2. And we're looking at inches cubed. I hope you got the same answer. Now let's look at the volume of composite figures. Volume of composite solids. When a composite solid includes cylinders and cones, you can find the volume by decomposing it into solids whose volumes you know how to find. For example, example 3, has a cylinder and a cone. We find the area of the volume of the cylinder and we find the volume of the cone, and then we add the two together, right? So here you can see that they're finding the volume of the cylinder first, right? Because you know the formula for volume of a cylinder. They plug in the variables or replace the variables with the values, the dimensions, and they find the volume of the cylinder. Then they use the formula for finding the volume of the cone, and they find that. And then at the very end, they add the two, as you can see right here. They add the two, and that gives them their total. So, guess what? It's our turn to try it. And you can see right here that we have a cone, and another cone, right? We have 2 cones with 2 different heights, same radius. So the radius of 6 can be used for both formulas. For the one cone, we have 13 inches in height, and the other cone, 5.5 inches in height. So let's find the small first, and then we'll find the larger one second, and we will add the two. Pause the video and try this on your own now. I hope you paused the video and you are ready to check. I have written the formula down twice because I'm looking for a cone twice, right? So this one will be for my smaller cone, and this one will be for my larger cone, and I'm going to try to do them simultaneously. Okay, now I'm going to replace my variables, and you can see that I've replaced the variables with red. Okay, so in this one, my radius square is still 6, and my height is 5.5, and here, again, it's the same radius, because they share the same circle, it's 6, and my height is 13. 6 times 6 is 36, so I don't think I have to write that line down for you, since you already know that. 6 times 6 is 36, and then that 36 needs to be multiplied with all these other factors, and here as well. The only difference is it's not being multiplied by 5.5 here to be multiplied by 13. Okay, so my next line looks like this. The smaller cone, the volume is 207.24 inches cubed. And the larger cone, the volume is 489 inches, decimal 84 inches cubed. And now I need to add the two so that I can have the total volume. And when I add the two, I will have an answer of, not remember it. You know that I have to add it, so it just goes right there, and I can simply go plus 489.84, and you know that already. And I get 697.4 inches cubed. Now, actually, this is what I get when I use pi, but when I don't use pi, when I use, the function pi on my calculator, but when I don't use the function pi on my calculator, and I simply use 3.14, I get 697, that's the same, 0.01 inches cubed. So both of these answers are acceptable because they are both an estimate. So the line should really look more like this. The equal sign should be more wavy. Okay? Well, I think that is it for this lesson. See you in the next lesson, everyone.